Properties of matter. Here's a riddle for you to ponder. What do you and a tiny speck of dust in outer space have in common? Think you know the answer? Read on to find out. What is matter? Both you and the speck of dust consist of atoms of matter. So does the ground beneath your feet. In fact, everything you can see and touch is made of matter. The only things that aren't matter are forms of energy such as light and sound. Although forms of energy are not matter, the air and other substances they travel through are. So what is matter? Matter is defined as anything that has mass and volume. Mass. Mass is the amount of matter in a substance or object. Mass is commonly measured with a balance. A simple mechanical balance is shown in the figure below. It allows an object to be matched with other objects of known mass. SI units for mass are kilogram. But for smaller masses, grams are often used instead. Mass versus weight. The more matter an object contains, generally the more it weighs. However, weight is not the same thing as mass. Weight is a measure of the force of gravity pulling on an object. It is measured with a scale, like a kitchen scale, in the figure below. The scale detects how forcefully objects in the pan are being pulled downward by the force of gravity. The SI units for weight is in newtons. The common English unit is a pound. With Earth's gravity, a mass of 1 kilogram has a weight of 9.8 newtons, which is 2.2 pounds. An object with more mass is pulled by gravity with a greater force, so mass and weight are closely related. However, the weight of an object can change if the force of gravity changes, even while the mass of an object remains constant. Look at the photo of the astronaut Edwin E. Aldrin, Jr., taken by fellow astronaut Neil Armstrong, the first human to walk on the moon, in figure below. An astronaut weighed less on the moon than he did on Earth because the moon's gravity is weaker than Earth's. The astronaut's mass, on the other hand, did not change. He still contained the same amount of matter on the moon as he did on Earth. The amount of space matter takes up is its volume. How the volume of matter is measured depends on its state. The volume of liquids is measured with measuring containers. In the kitchen, liquid volume is usually measured with measuring cups or spoons. In the lab, liquid volume is measured with containers such as graduated cylinders. Units in the metric system for liquid volume include liters and milliliters. The volume of gases depends on the volume of their container. That's because gases expand to fill whatever space is available to them. For example, as you drink water from a bottle, air rushes in to take the place of the water. An empty liter bottle actually holds a liter of air. How could you find the volume of the air in an empty room? The volume of regularly shaped solids can be calculated from their dimensions. For example, the volume of a rectangular solid is the product of its length, width, and height, L times W times H. For solids that have irregular shapes, the displacement method is used to measure volume. You can see how this works in the figure below and in the video below. The SI units for solid volumes is cubic meters, excuse me. However, cubic centimeters are often used for smaller volume measurements. Be sure to watch the video. Physical properties of matter. Matter has many properties. Some are physical properties. Physical properties of matter are properties that can be measured or observed without changing to a different substance. For example, whether a given substance normally exists as a solid, liquid, or a gas is a physical property. Consider water. It is a liquid at room temperature, but it freezes and changes to ice. It is still water. Generally, physical properties are things you can see, hear, smell, or feel with your senses. Examples of physical properties. Physical properties include state of matter and its color and odor. For example, oxygen is a colorless, odorless gas. Chlorine is a greenish gas with a strong, sharp odor. Other physical properties include hardness, freezing, boiling points, the ability to dissolve in other substances, and the ability to conduct heat or electricity. These properties are demonstrated in the figure below. Density. Density is an important physical property of matter. It reflects how closely packed the particles of matter are. Density is calculated from the amount of mass in a given volume of matter using the formula density equals mass divided by volume. To better understand density, think about a bowling ball and a volleyball. The bowling ball feels heavy. It is solid all the way through. It contains a lot of tightly packed particles of matter. In contrast, the volleyball feels light. It is full of air. It contains fewer, more widely spaced particles of matter. Both balls have about the same volume, but the bowling ball has a much greater mass. Its matter is denser. Chemical properties of matter. Some properties of matter can be measured or observed only when matter undergoes a change to become an entirely different substance. These properties are called chemical properties. They include flammability and reactivity. Flammability is the ability of matter to burn. Wood is flammable, iron is not. When wood burns, it changes to ashes, carbon dioxide, water vapor, and other gases. After burning, it is no longer wood. Reactivity. Reactivity is the ability of matter to combine chemically with other substances. For example, iron is highly reactive with oxygen. When it combines with oxygen, it forms a reddish powder called rust. See the figure below. Rust is not iron, but an entirely different substance that consists of both iron and oxygen. Lesson summary. Matter is anything that has mass and volume. Mass is the amount of matter in a substance. Volume is the amount of space matter takes up. Matter has both physical and chemical properties. Physical properties can be measured or observed without matter changing to a different substance. Chemical properties of matter can be measured or observed only when matter undergoes a change to become an entirely different substance.